This is a prototype Whyte Kado, and we've got exclusive access to see how this bike came to fruition. Come along, see how it was done. Whyte is one of the most loved mountain bike brands coming out of the UK, and we've got exclusive access to their R&D facility. Their lead engineer, Sam Shucksmith, is one of the fastest enduro racers in the country and certainly has the skills to pay the bills. We're going to go to the facility to see how the bikes are developed, designed, tested, prototyped and ultimately brought to market. So with that, let's go and meet the team. All right, so Ian, you're in charge.
Am I?
I think.
Well, I'm Ian Alexander. I'm the chief designer at Whyte, and I mean I've been here getting on, I think it's 23 years this year.
Why do you guys build bikes that are, I guess, at the forefront of what mountain biking is?
Well, it's a good question. I mean, it's sort of necessity with Whyte. I mean, when you look at the sort of context of the global bike industry, there's a lot of competition. You have to come up with genuinely innovative stuff. It's not good enough to just come along with some great colours or graphics or, you know, ultimately you ride these things and it's an experiential sort of product that you go and ride and people evaluate it really critically. When the guys were doing the first bike, they had to find a big advantage, and that was sort of built into John Whyte's DNA. He was in Formula One. You know, you only win in Formula One if you've got an unfair performance advantage. And he just translated that into what they were doing in the bicycle business. And of course, at the time, telescopic forks were rubbish. They didn't last. They were designed in California in the dust. They just chucked that out the window and just literally fabricated something that was better, that they knew would work. That's what we do, and it just rolls on and on and on. You know, the next new bike comes out of the previous bike, and so the guys are just constantly working on what comes next. Mm-hmm. We're in a sort of a competitive race against other bike brands, but also against the terrain that these bikes get used on.
Well, I think we better go and see how one of the latest bikes you've created, the Kado, has been developed. So that's going to be today's mission, I guess, to see how it's all done. All right then, so Ben, you are the product manager for all bikes, or mountain bikes, or e-bikes, or what are you?
Yeah, cover the whole range, yeah.
Okay, great. And what does that entail?
So, yeah, it basically entails the whole product process from start to finish and all the way through then after sales as well. So, obviously at the product inception, you're setting out the product brief. Then throughout the product design and development stage, you're working with the R&D team, you're with Louis, the industrial designer, and then moving on to work with Clayton on the graphics side of things, as well, of course, working really closely with Sam on the kinematics, the geo, how we can then marry best the product brief with Sam's idea on where he wants the product to go in terms of design, kinematics, ride feel, all the way through to working with suppliers on what components are going to be spec'd on the bike, overall pricing, the range itself, how wide, how many models we want, and just managing the introduction of a new product either to replace old or to fill a new gap in the market, and then just all the way through to working with marketing, releasing the product into the wild, and then getting rider feedback. So we're trying to distill the ride feel of the bike and also then consumer feedback and trying to marry that together into the next direction of what we see. For talk's sake, the outgoing E160, it's transitioned into Kado, what we then think that next model needs to be, what features we want to target in Kado that E160 maybe didn't have.
What's the starting point and how do you sort of decide what needs to be made and what it needs to look like?
I think primarily the first starting point is always going to be the rider that it's for. In very basic terms, is it full suspension, is it hardtail, is it a gravel bike? That allows us to tick some of the easy boxes in terms of suspension travel, frame materials, so either carbon or aluminium options or both in the range. Whilst we get down on paper what the design brief needs to be, it's very much collaborative. It generally transitions from one set of hands to another, but it's always sense checking it against other members of the team as well.
So that's kind of how a bike is formulated, but let's go and talk to Sam about how it's actually designed and then built. All right then Sam, so you design the bikes, is that about right?
Yeah, with the team, of course, yeah. I'm head of mountain bike design, so doing all things mountain bike and mostly full suspension.
Cool, and you've got a background in engineering and racing.
Yeah, that's right, yeah. Did engineering at university and been racing bikes since my early teens. So.
We've chatted to Ben, who's sort of talking about how like the whole idea of a new bike comes about, but the next step, I guess, is designing it from the ground up.
Yeah.
And I guess that sort of falls in your ballpark?
Yeah, so with the Kado, it was basically taking the E160, which is a really successful bike, onto the next, the next stage. And we got really positive feedback on the E160 in terms of how it rode. So we didn't really want to change that, but we wanted to take it on and evolve it. So in terms of the bike and the way it's constructed and it's designed is completely different. We're trying to keep the DNA pretty similar to the E160.
Okay.
One of the key aspects is obviously bringing it up to date with the latest Bosch system.
Because you've got to sort of almost build a bike around that system. That's the starting point.
Yeah, it pretty much is for an e-bike. So the first stage really is positioning the motor and the battery in a configuration that gives you the lower centre of gravity, and that's kind of the next stage to that is fitting in the kinematics, all the pivot points.
Okay, Sam, so on the screen, I can see some graphs. I can see some like very 2D technical drawings of bikes. You sort of quickly talk like, is this the starting point?
Yeah, it does start 2D, definitely with a sketch, and then you kind of start to flesh out more and more in 3D.
Right.
To the point where it goes over to Louis to do the real 3D.
The suspension kinematics of a full suspension mountain bike is super important as to how a bike actually feels. So how do you design how the suspension is going to feel, especially considering that you can't have the pivots maybe in the optimal position because there's a motor there?
Exactly, it's all just a big kind of juggling act really, but I think the first step is knowing actually what you want to achieve.
Okay.
And that's kind of comes from experience riding lots of different bikes. There's lots of different kind of philosophies on how a bike should ride and how a bike should feel, and just starting out on the right philosophy is obviously very important to getting the good end result.
Okay, so we've done sort of the 2 and 3D design here. We've got our kinematics, we've got our centre of gravity, we've worked out that we can fit a water bottle in there or a range extender in there. Next up then, it sounds like it's the industrial design with Louis over there. All right, so Louis, what are you?
So I'm an industrial designer.
Okay.
I studied product design at university, moved to Whyte about 3 years ago.
In its simplest form, what is industrial design? It sounds quite like technical.
Really, it's just the development of new products.
So you have like an overall view of everything from the start of the project all the way through to the product coming to the shops?
Yeah, pretty much. Yeah, it starts with like a design brief, typically then some sketch work, which we then take into CAD development, prototyping, right the way through to manufacture, whether that be for carbon fibre layup or injection moulding if it's a plastic part,
Okay.
or die casting if it's metal.
Yeah. And so are you working very closely with Sam, I guess, in that respect?
Yeah, pretty much. Yeah, we work together. Yeah, pretty much all hours of the day. He'll basically send me a geometry sketch with the kinematics in place, and then I'll basically clad around that with surfaces, do some sketch work initially, like preliminary, and then take that into CAD.
Okay, so there's a few sort of sketches.
Yeah, some initial sketch work. That was for the E-Light project a few years ago.
Right.
So yeah, just some quick sketches exploring how we're going to make it modular basically for the SX and the CX motor. So yeah, just some rough stuff that we can then use to kind of speed up the development rather than going straight into CAD.
And then I guess like round the head tube, for example, there's going to be sort of quite a lot of different shapes that you're designing, engineering to make sure that it all fits together. You can put the module for the display for the e-bike in there, the cable routing goes in there.
Yeah, everything, yeah. So I'll start with the silhouette and then I'll basically block in kind of the initial kind of surfaces for the front triangle and the back end. And then as the kind of model progresses, I'll then add in like the mounting points for the motor if it's an e-bike, head tube grommets, cable routing, system controller, and then you get into the finishing parts such as the ancillary like down tube protector, mud guards, things like that.
Okay.
So yeah, it's the full package really.
And I guess you're going to be having conversations with Clayton, who we're going to speak to in a minute.
Yeah.
Along the way about how the colours are going to interact with the shape of the frame and logo placements and stuff.
Yeah. So yeah, we work together quite closely as well. I'll send Clayton a few images and we'll discuss how he might potentially mask a certain area of the bike and potentially how a crease that I put in or a facet I put in on the frame might lend its way to a graphic or something that he's kind of working up or has an idea for.
I guess there's always a bit of pressure maybe to have a range of bikes that look consistent, so there's a feel of what Whyte looks like.
Yeah.
That's got to be a challenge when you're doing hardtails, you're doing long travel stuff, short travel stuff, e-bikes, analog bikes.
Yeah, just trying to introduce features in a frame that are kind of transferable across different projects. Something that we're trying to do moving forward, but obviously that's got to translate into both carbon and alloy.
Okay, so Louis has done his industrial design, you've got like a 3D model of what everything's going to look like, and then you whack it into this FEA to work out if the frame's going to snap.
Essentially, yeah.
Right.
FEA, finite element analysis, just a numerical technique to simulate the forces and loads on a structure.
Okay.
And we use that to replicate the tests that the bike's going to go through, both in the lab and in the real world.
So it's kind of computer-based testing before you have to commit to any physical bikes.
Exactly.
Okay, so I've just come across the office. Clayton, what is it that you're doing?
So I have the pleasure of doing all of the colours and graphics for our bikes, which is a really fun process. It can be tedious pleasing everybody because it's impossible to please everybody, but yeah, no, it's a really fun process. So once Louis passed it across to me, I had the 3D models and I can start to play around with graphics and play around with the paint finishes. First process we do is I'll choose a selection of colours, which can just be random. It can be colours that might have a trend for 2025, 2026, and I might choose several metallics, I might choose several shades of green, and then we get colour tubes in from the factories. So these are the samples sort of things that we get, and everything comes in a half matte, half gloss, because each finish has different properties and you can see the different way it affects light. Either can then start to update the colours. So this is the really fun bit. Once I've got everything laid out with my graphics, I can very easily just choose a colour that I've pre-mixed, and, I can literally just drag and drop and play. And then you can see how it looks in different lights and different environments.
You play around obviously with a lot of colours, which means you must have a favourite colour. Which one is it?
I'm a green or a yellow man, old school British Racing Lotus colours. I think that's where I go. Yourself?
I think this. The little turquoise, the orange with the flecks. I'm into that. I like that a lot.
Nice, good choice.
So whereabouts in the development process do you really come in? Do you come in when there's actual bikes that have been built, or do you come in before anything's been manufactured?
So I try and stay as in touch with the timeline on the manufacturing side of things. So Louis continually giving me updated models and the 3D to work with. When we get our first set of ride samples in, that's when I like to start to apply paint. I might not have a finished name for it, I might not have a finished graphic for it, but if I can get some sort of paint on it, I learn a lot from the ride samples, where wear's going to have an effect, where tyre rub might happen, where I might have to have an extra layer or two, or there might be like masking in certain areas for bearings and the press fit might be too tight. So yeah, I try and get involved as early as I can if I can keep up with the process over there, because it's much quicker than mine.
All right, so we're back with Louis and we're going to talk about some rapid prototyping, which means that you can basically build a bike really, really quick, but you can't ride it.
Yeah, correct. So when we've kind of refined a frame, for example, we'll basically send it over to the 3D printer to check its form and then any clearances.
Okay. Okay, and you can mount forks, wheels, drivetrains to it.
Yeah, so we'll build it up as a full bike, but really it's kind of a quick way for us to check form, check kind of like initial assembly with ancillary parts as well as frame components. It's useful to present ideas to the rest of the company when they've got something tangible to kind of interact and look with.
I see.
Yeah.
So we do it on screen here first. You create the shape that you want the 3D printer to print, and then it whizzes over to there.
Yeah.
I think that's what we should go and do. All right, so this is your 3D printer.
Yeah.
It's printing. What is it?
This is our flagship 3D printer, and it's a process called FDM, Fused Deposition Modelling, and it prints with a material called PLA, but each segment probably takes about 12 to 24 hours to print, so it's about a week's worth of printing time. You know, if you're looking at the kind of the battery removal system on the Kado, where you've got like a hinging mechanism, locking mechanism, to kind of create that, we went through 50 different iterations, just like fine-tuning tolerances and part interaction and things like that. So yeah, it's really, really useful.
Okay, so this is Will. You work here at the Whyte R&D facility. What is your role?
So my role is junior mechanical engineer, and that involves some design analysis, and running the centre of gravity rig. So centre of gravity is particularly important in handling of the bike.
And do you want it high? Do you want it low? Do you want it at the back?
You want
or
it
the front?
low and central.
Low and central.
Yeah, nice and even front to rear, and just under your feet, so you get really optimal handling performance.
having a lower centre of gravity just makes the bike calmer, much more predictable, more neutral for the rider. The rider can just remain totally focused on riding the bike. And that always liberates much more confidence, and confidence is absolutely vital, key to having a good ride.
So, bike's on here, your bathroom scales are turned on, there's a laptop there. Can we see what's going on?
Yeah, definitely. So on the screen here, we've got the, this is the representation of the centre of gravity.
Okay.
This red dot here, and that's relative to the free load cells that we have in the centre of gravity rig.
Okay.
And then we're using these values, we then do some sort of post-processing to make the centre of gravity relative to the rear axle to span the whole wheelbase of the bike.
Sure. Okay, so we've got a centre of mass, you've ticked your box, you're all happy. I guess the next thing is to go and test the bike.
Absolutely.
Okay, so we've done the 3D printing, we've got ourselves eventually an aluminium or a carbon mule, and I guess the next thing you've really got to do is test it. Is this the exciting bit?
So there's a whole plethora of different tests that have to be conducted according to the standards, but we go way above the standards.
Okay.
And yeah, there's bikes tested from every single angle to simulate kind of every single riding situation in fatigue and impact.
So this testing, you're talking about impact testing, stiffness testing, what sort of thing goes into it?
Yeah, so there's three main parts. Is the stiffness to identify how stiff your bike is, which is going to have a big impact on the ride feel, and then fatigue, which is cyclic loading over and over again, and then impact, which is usually a one-off hit.
Okay then Sam, so we have got this telemetry stuff on the table. We do have a bike here. Can we get it fitted and then go and sort of see the process in action?
No. Let's do it.
Alrighty. Okay Sam, so we're out here, local test tracks, it's pretty rocky and loose. You've got some telemetry bits bolted or zip tied to your frame.
Yeah.
You've got it on your fork, on your shock, and this bit of computer down here. What are you collecting? What data is it that you're getting out of this?
Yeah, so the sensors on the fork and the shock, they measure the amount of travel that the fork and shock are going through. And then the kind of data unit here, that has accelerometers and gyroscopes and can measure the acceleration of the bike. But mainly, I mean, the two really basic, simple things to get nailed, the dynamic sag, which is kind of like your average position, your average sag, so not just sitting on the bike sag, it's like ride down the trail and then it calculates your average sag.
Okay, so where the bike's hovering around and it's travel outside of big
after
shocks.
each compression and rebound, where it kind of settles to.
Yeah.
And then on top of that, you've got your compression and rebound speeds, and that's how you start to dial in your compression and rebound and your air pressure, and you got your spring curves, your progressivity, and the most important thing is it's obviously looking at the front and the rear, because ultimately to get the front and the rear balance to make a confident ride is absolutely crucial.
So you'll be doing plenty of test runs, different setups as you go along, as consistent as possible down the same tracks over and over and over and over again.
Yeah.
And then you whack back to the office, you dial in the numbers into your computer and you sort of come up with, you know, the tunes for your suspension and all that sort of stuff, just to make sure it's all perfect.
Yeah, kind of. I mean, I check the data after every run and make incremental changes. And you're kind of looking for that feeling. And if you can't get it, maybe you're right at the end of the adjustment range of a certain tune, then obviously that would be a cue to try a different tune, or maybe just the feel. You know, the computer says great, but it's just not the ride feel you're looking for.
Yeah.
And then you got to look at something else. So the data's a guide. It doesn't tell you what to do. It doesn't tell you whether it's good or not, but it's useful data to kind of steer you a bit.
So Sam, when you are out testing, like how many times are you going out for each bike? How many runs are you doing per day? Like, is it a lot or is it just a few sort of runs to check?
We do as much as we possibly can in the time you have from receiving the sample to having to sign off whatever it is you're working on to make sure you don't miss, the production date.
So you get back, let's assume that you've got the tunes right, everything's running perfectly. From there, I guess it's back to Ben, who's going to be talking to the vendors, to the OEMs, to the factories, who bet it all together into these complete bikes. Ship them to the UK, ship them to the distributor, ship them to the shop, ship them to the consumers, and boom, you've bought yourself a brand new Kado. Is that roughly it in a very compressed sense?
In a very compressed sense, sounds bang on.
Sam, thanks ever so much for showing us how sort of the Kado has come to fruition. It's been a really interesting day. It's been great meeting the team at Whyte. So yeah, thanks ever so much for your time. Big up to Whyte for sponsoring this video. Now Sam is going to go and ride down some loose rocky terrain, but if you want to see a video of me doing the same, head to our video where I rode down Mount Etna a few weeks ago. It was a pretty wild ride.